Now we want to extend the graph into the third and fourth quadrants, and there's actually a very simple way to do that. Let's just consider this point on the graph, corresponding to this first quadrant point. This point on the circle, which corresponds to this first quadrant point on the graph. If we were to subdivide this right angle, we would get angles that mimic these angles. We would get lines that simply extend the lines that we've used to bisect our angles. So in particular, the line for this point would extend. And let's see if I can do a halfway decent job of that. This chalk doesn't have a good point on it. Okay, that should work. Okay, so now I've extended. Well, I haven't done a really good job of it, but I've extended this line, giving us a point down here. Now, this point on the circle corresponds to this point on our graph. If I go 1, 2, 3, 4, 1, 2, 3, 4 points to here, well, that would give us a point over here that corresponds to 1/4 of this distance. And that could obviously be constructed with compass and straight edge, probably no more accurately than I estimated it by my eye, but there are going to be inaccuracies either way. Okay, well, I could project this point all the way over here, and hopefully do a better job of it than I appear to be doing. And if I did, and if the construction is perfectly accurate, again, I'm going to leave it to you to think about how to prove this. But the coordinate that I get for this point, the y-coordinate, or the vertical coordinate of this point, the vertical position that would be projected over here, is going to be the same as this, only upside down. So this point will reflect to a point that's about here. I'll mark that lightly. And similarly, this point up here is going to reflect to a point that's an equal distance below this point, somewhere along here. And the question is, how can we best, what are our options for actually constructing the coordinates of these points? One option, obviously, is to subdivide everything here and project as we've done. But maybe just using the points on this graph, what's the most efficient way in which we could get these points? Okay, so you might want to think about that, and we'll continue that in a minute. Unfortunately, I didn't have this camera working when I did this construction, so I'm going to have to just indicate the reasoning and so forth. Okay, so what I do, for every point on this part of the curve, I can reflect it through this point. I think we've seen that. I'm not sure where this video started and stopped. The alternative series of shorter videos gives the entire picture of this construction, the entire reasoning. But I take each point on this graph and reflect it through this point. How do we do that? I sketched the line, or at least a portion of the line, through this point and this point. Extended it far enough, extended at least far enough on the other side of this point to match the distance of this point from this one. Okay, so then I can use the compass, and let's see, how do I want to do this? Okay, I'll do it like, well, let's use this hand. Let's see if I can get my fingers to work in this direction. Okay, so there's the distance. spread my compass to this distance, come over here, mark the same distance on the other side, and I get a point. I do the same thing for each of these points, and I get these reflections. Now, the X is marked where I kind of thought the reflections were, but remember, this isn't very accurate. And the use of a chalk line to approximate the line through 2 points is a little fuzzy too. So I got these points here. Taking this point as a more accurate reflection, I then kind of fudged the curve, so I kind of missed these points. But if this had been constructed with absolute precision, which is the assumption that we can do this, or that this can at least theoretically be done, these points will lie on a curve that has exactly the same shape as this curve, but turned upside down and positioned over here. If I then do the same thing through the points on this side of the curve, and this side of the curve was just sketched, it wasn't constructed very accurately. It's a little too fat, if that makes any sense. These points don't reflect as well as these points did, so that I'm not going to be all that close to this curve. But if I reflect all the points here, I'm going to get this curve. Okay, I'm going to get points that lie on a curve very much like this one, so that I've reflected this curve through this point to get this part of the curve. And I can relate everything that I've done here to what would be done had I done the entire construction all the way around the circle.